As we go into the field of wireless technology, there's a concept known as asynchronous transfer mode. And this asynchronous transfer mode, we will be discussing about certain things like what is it basically and how does it work. So it is basically a switching technique that is used by data replication networks that uses asynchronous time division multiplexing to encode the data into small fixed cells, just like how we have packets and networking. It supports voice, video, and data communications, and the size of each of these ATM cells is about 53 bytes. Out of these 53 bytes, we have 5 bytes for as a header and 48 bytes as the byte payload. In this asynchronous transfer mode, there are two different types of cell formats. One is the user network interface, and the other is a network interface. Now, what are the benefits of ATM networks? It provides a dynamic bandwidth that is particularly suited for bursty traffic. Since all data are encoded into identical cells, data transmission is simple, uniform, and predictable. Uniform packet size ensures that mixed traffic is handled efficiently. Small size header reduces packet overload, thus ensuring effective bandwidth usage. ATM networks are scalable, both in size and speed. When you look at the ATM model, it is always related to the OSI, that is the Open System Interface model that we use for networking. And it's comprising of the physical layer, the ATM layer, and the ATM adaptation layer. In the physical layer, this corresponds to the physical layer of the OSI model, where all the cells are converted into bit streams and transmitted over the physical medium. ADM layer is a layer comparable to the data link layer of the OSI model, where it accepts 48 byte segments from the upper layer and 5 byte header to each segment and converts into 53 byte cells that is used for transformation of data. The ATM adaptation layer corresponds to the network layer of the OSI model, which facilitates the existing packet switch networks to connect to ATM network and use its services.